Okay, so today we will be having another example for case-based reasoning, and it will be about medical records of 6 patients. So if you will notice here, we try to predict. Okay, in this case, we want to predict, or we want to determine if one patient is having chronic kidney disease. Okay, we want to know if the person is having kidney disease. So this we want to predict if the person is having chronic kidney disease based on the following symptoms. Okay, so normally in the medical science, for us to know if a person is having kidney disease, this thing should be present. Okay, at least levels of measurements should be present with this person. So in this example here, patient 1, the blood pressure is 90, and then he has albumin 1, the value of 1, and then sugar is 0, and then red blood cell is normal, and then anemia, he is having anemia. So the conclusion of the doctor is this person is having chronic kidney disease. So he is having um, problem with his or her kidney. So same thing, we have second patient here, blood pressure is 70, albumin is 1, sugar is 3, red blood cell is abnormal, and then anemia. He's not having anemia, but he was diagnosed to have a chronic kidney disease. So from this given medical history of 6 patients, we will try to predict what do you think would be patient X. So let us know if patient X is having chronic kidney disease or not. So the decision point here is very simple. The decision is very simple. If the answer is yes, and then the person has kidney problem. Okay. If the answer is no, the person has no kidney problem. So we want to determine using case-based reasoning if the person is having kidney problem or not, based on the following symptoms here. So before we calculate this one, I want you to make observation on how data is presented here. So on the blood pressure, what kind of data are this? Blood pressure is what kind of data? Continuous or discrete? So blood pressure is, let's try to talk first with the data types. Okay, or types of data. So blood pressure is continuous or discrete? Blood pressure is continuous or discrete? These are represented in numbers, right? So they are continuous. Okay, they're continuous data. How about for the case of albumin? What kind of data is albumin? Albumin is represented in numbers, so we have to call it also continuous. Okay. Next, how about sugar? I think sugar also is continuous, right? So you have to look at it. you have to look at it if what kind of data you're working with, because we'll be using a separate formula for each data. Okay, so how about the red blood cells? What kind of data we're working here for red blood cells? Red blood cells, it is discrete, right? Because it's represented with non-numeric values. So discrete in a sense, either normal, abnormal. So we only have two measures here for the red blood cells. Either the patient is having normal or abnormal red blood cells. And then also for anemia, what kind of data we're working with for anemia? It is also discrete. Okay? So these are the types of data we'll be working with this problem. So please make note of this. These are very important on the choice of formula we're going to apply for this calculation. Any question here so far? Any question here?
Questions?
Yes?
No questions.
Okay, thank you so much. So let's go back with the PowerPoints that we used last time. Okay, we have two formula for the calculation of the similarity. We have one for discrete and one for continuous, right? So we have two formula for that. One is discrete and one is continuous. So we have to copy this formula because we're going to use them in the example. So let me just run it and go with the print screen, escape. Let me just go with paint. Let me just put the formula here. Okay, so these are the formula we're going to use for discrete, and we're going to use this formula for continuous. Let me just paste them here so that you will know them later. Okay, so let's try to make a table for this. Let's make a table. So we have 1, 2, 3, 4, 5, 6, 7, 7 by 8, right? So you have to make a table. You have to make 7 by 8. Let me change the it's not linking to table. So we need how many? As I've told you, 7 by 8, right? So we have to count this. 1, 2, 1, 2, 3, 4, 5, 6, 7, and 8 here. 7 by 8. 7 columns and 8 rows. So let's go back with this. have red blood cells. Okay. And the next one is anemia. And the other one is chronic kidney disease. Okay. Okay. So you'll try to calculate the similarity of this. Okay. So this is our patient here. We have 75, 1, 1, normal, no. Okay. Are you ready? So to begin with, let's start having blood pressure. Since we mentioned earlier that blood pressure is continuous, so we have to follow this formula. Okay, so we have to follow the formula 1 minus A, which is this one, 75. So for us to be able to know it, let us summarize here the values. So A equals, how much is A? Is 75. Okay, so let's go with the, let me go first with the patients here before I proceed. Patient 1, Control C. Patient 1 here. Patient 2. Patient 3 we have. And we have patient 4. We have patient 5. Patient 6. And lastly we have patient X, right? You just have to write in here patient X so that we will know patient X. So let's write all the values for patient X here. Patient X is having 75. For 75. You just have to make the calculation faster. And the other one is 1, 1, another one is series 1, and the other one is normal and no. Basis no. Okay. Okay. So let us see the value here. For this, let's try to calculate for blood pressure. So what's the blood pressure of the first case? 90, right? So we have to follow this formula. 1 minus A minus B over the range, which is in this case we have 75 minus 90, correct? But we have to calculate first for the range. Okay, So let's try to see the range for the following. Let me just write in here range, so it will be very easy for us. Range. Okay, so for the blood pressure, since it is in the continuous, we have to calculate the range here. So range is very simple, we know it. Highest range means highest minus lowest, right? Let me just write in here highest value minus the lowest value here. So for the blood pressure, the highest is 90, and the lowest is 70, right? So for the range of the blood pressure, it is 90 minus 75. So 90 minus 70, right? So it's 90 minus 70. So in this case, we can now calculate it. What's the value for this? So 90 minus 70, you will get it 20. Good. Next, for the case of the albumin, since albumin is also continuous, we have to calculate it, right? Albumin is continuous, so we have to calculate it. So it should be 4 minus 0, right? We have to write it in here. 4 minus 0 equals 4, right? So the range for the albumin is 4. Next, for sugar, it's also continuous, so we have to get the range. So 3 minus 0, it's 3 minus 0 equals 3. So we have to place this here as the range. How about for red blood cells? Do we need to calculate the range for red blood cells? We don't need, right? Because you cannot subtract abnormal from normal, so we don't need range here. How about for anemia? Do we need the range here? Also, no, we don't need range for discrete values. So if you will notice, this two here, these two here are discrete, right? These are discrete. So this problem is a combination of the discrete and continuous values. Okay, so we can now proceed, I guess. Let's start. So let's calculate the blood pressure for this. So we have 75. So we have the range here in the bottom. So we can now do the calculation. So normally when I calculate the CBR like this, it gives me a faster way on how to view things around me, and I can do the calculations faster. I hope you are doing it in paper while you are listening to this presentation. So let's now start. Following this formula, we have 1 minus A over minus B over the range. So you could write the formula here. This is 1 minus the absolute value of the value here that we have is 75 minus, you can get from here, 90. So you could write it in here, 90 over the range which was given to you here in the bottom, which is 20, right? So this is a little bit faster. And then put it in here, the table, then put the value here, so you could get the summary of it. So when you calculate it, it should give you 1 minus shift the absolute value of 75 minus 90, then you have to divide it by 20. So you will get here something like 1/4, which is 0.25, 0.250. Okay, so by the way, let me give to you the PDF in the chat board so that you can calculate it with me. Next, let's proceed to the next one, which is you can copy this and paste it in here, then just simply replace the value of the next one, which is in this example we have 70. Okay, I think this is 100%, right? 1. I think this is 1, because no, this is 75. No, this is not 1. So 75 minus 70, let's calculate it, please. So let's try to move here. Let me replace 75 with 70. So I will get 3/4, which is 0.75, 0.750. Then paste it again. What's the next value? The third patient, 90, right? So if you will notice, if you have values which are synonymous with one another, no need to recalculate. Since it is 90, just the same with the first one, so it will get the same value, which is 2.250. Now let's get the fourth one. What is the fourth patient? It's 80, right? So it is 80. So we just have to replace this with 80 here. And I guess all of the succeeding patients are 80, right? So calculation is not that challenging for you. So let's proceed with the 80 here. Let's calculate it. Just go to your calculator and replace 70 with 80. Then equal sign 3/4. It says 0.75. Why it's something? Yeah, because it's above. Yeah, so it's 0.75. So we just have to replace this with 0.750. Then just copy this, because since the remaining patients are having the same values. So we are done with the fifth and the sixth patients. Let's now proceed with the albumin. So again, these are continuous. So let's see the value. This is 1. The range is 4. So we can now go with the calculation and just get later on the value for the first case. So in this case, we just have to write 1 minus the absolute value of 1 minus, later I'll put it, divide by 4 as the range. So what's the value of the first patient? It's 1. So let's just have to write 1 here. Then let's place this on the first table. So in this case, we will have this. Since they are the same, I guess they will get 100 here, or 1. So this is 1 minus shift absolute value of 1 minus 1 divided by 4 you should get 1, right? So you just have to simplify the calculation. Let me give you the technique. If the new and the old are the same, automatically you have to write 1, okay? Because they're the same. So basically they are the same, so they will get the value of 1. So this is it. So just copy this again, paste it to the next column here, cell here, and check the value for the second patient, which is 1. So you will see patient 2 and patient 1, they have the same value. So you just have to take or copy paste the value here. No need for you to recalculate it, just the same. Then let's go with 4, which is albumin. Let me copy the formula here and paste Ctrl Z. So 1 minus 4, we just have to change it here, then calculate it with the calculator to see the value. Just replace 1 here with 4, press delete, then with 4, then press equal. You will get 1/4, which is 0.25. You have to write in here 0.250, and then copy paste that, put it in that column. So please check if this has the same case here, so that we just simply copy paste it. 4, right? 4, so nothing. So the next values will be 0, so just press V here, then replace this with 0. Okay, calculate it, replace 4 with 0, then press enter key. You will get 3/4, which is 0.75. 0.750. So you will see patient 4, 5, 6, they have the same value, 0, 0, 0. So we just have to copy this to the rest of the cells. Let me just place it here, and this one, Ctrl C, V, V, make it 2 copies of this, and paste it here. That's it. Any question here so far? Any question here? Please tell me if you don't have questions. Either chat it or answer my question in the conference. No question?
Doctor,
Yes, there.
for X, how solve it?
X is the patient. X is the 7th patient. This is actually patient 7. Okay? It is patient
Okay.
unknown. Yeah. This only number. This is the ID only of the patient here. Okay, can I proceed with the sugar?
And for range,
Yeah.
low and high, so yeah.
Yeah, for the range, this one. You just have to get it
Okay.
from here. 90 minus 70. So we got 20 here. This one.
Okay, thank you.
No problem, dear. Let's proceed with sugar. Okay. So the new case is 1. So we can write something like 1 minus the absolute value of 1 minus, later we will take it, divide by, how much is the range? 3, right? So let's check what's the value of the first patient here for the sugar, right? So it's 0. You just have to replace this with 0. Okay, so go to your calculator, replace 4 with 3, then this one, just press equal sign. You will get 0.67. So this is 0.670. What's the value? Let me just get it again. 0.667. Okay. So copy this one here. Copy this. Let me just put this one here on the first spot for the sugar. And then let's go with the second one, which is how much? 3, right? Replace this one with 3. Then recalculate. So replace this one 0 with 3. Del, and then go with 3 equals 1/3, which is 0.33, I guess. Yeah, 0.333. Okay, so Control C. Let me just copy this, then place it here again. Next, the next patient is 1, right? So obviously speaking, since this is the same with the new patient, 1, 1, we'll just get it with 1 here, right? This automatically becomes 1. You don't need to calculate it because they're the same. So copy this and paste it here. Now let's proceed to the next, which is patient 4. 0, 0, 0, right? You're very lucky. It's similar to case 1. So 4, 5, 6, they have the same case with 0. With case 1 here with the value of 0. Just copy this. The calculation we've made for this, copy and paste it to the succeeding patients. So not much calculation is required for this. So copy this. Then paste it 3 times. And place it here. 1, 2, and 3. So far we're done with the continuous values here. We calculated the continuous values. Let us now proceed with the discrete, which is blood cells and red blood cells and anemia. So in the discrete calculation, it's very simple. لو نفس الشيء واحد لو ما نفس الشيء 0. If they are the same, we put 1. If they're not the same, we put 0. So just simply check it. If they are the same, then it's done. So our patient is normal. Okay, normal. Let's compare it if it's the same with the values here. Normal says 1. Abnormal is 0, right? Because they're the same. So normal, same. Look at this. This is our new case. Normal, same, right? Not the same. So this 0. So this same. This is same here, so on and so forth. So we will get the value of 1, 0, 1, 1, 1, 1. It's very simple. 1, 0, 1, 1, 1. And just copy this. One, 0. No need to calculate for discrete. In the discrete values, you don't have to calculate it. Just simply check if they are the same. If they are the same, 1. If they're not the same, 0. Clear here? Now let's go with anemia. Anemia says the new patient has no anemia. Let's see the similarity with the other cases here. The new patient, no anemia, so we have 0 1 0 1 1 1, right? 0 1 0 1 1 1. Zero, one, 0, Control V. This is 1, sorry. 1, 1, and then 1. Okay? So we are now done with the local similarity calculation here. This is now the time for us to calculate the global similarity. So what shall we do with the global similarity? So you just have to go to the PowerPoint and check the formula for global similarity, which is this. Okay, we just have to take a snapshot of this. Okay, and just paste it here. Okay, so for the global similarity, it says here we just have to get the total of the weights, 1 over the summation of the weights multiplied by the weights multiplied by the similarity of each. So since in our problem we did not specify what are the weights of each column here, so we don't have to multiply the weight, right? Because automatically all of them will get 1. So since we did not specify which column has the greater weight value, so we can just simply go with the total weights here. So total weights, let me just write in here, total weights would be very simple. 1 2 3 4 5. You just have to write here, since we have 5 cases with equal weights, 1 plus 1 1 plus 1 plus 1 plus 1 plus 1, so equals 5. So this is the total weights. Okay, total weights now is 5. Why 5? Why it is 5? Because for the reason the weight for blood pressure is 1, the weight for albumin is 1, the weight for sugar is 1, the weight for blood cells is 1, and the weight for anemia is 1. Because in the problem that we are solving, it was not stated what are the weights of each column here. So we will assume that all of them, they have equally with 1. So let me just put here, this is let me just write in here, weight is 1. Same with albumin, we'll write in here weight is also 1, because nothing was stated in the problem. So sugar weight is also 1. Same for the case of red blood cells. Weight is also equal to 1. For anemia, same thing, the weight is equal to 1, because we didn't state in the problem what weight each column should have. So we will assume all of them will get the weight of 1. So since the weight is all of them, they have equal weight. We don't have to, I think, multiply them by 1 here, because here in this example it says 1 over 5 multiplied by 1 times the value for 2.50, I mean 0.250, and then same until we get all of this here. So we don't have to multiply them by the weight. It's useless to multiply them by the weight because they're all using 1. So we could just simply summarize the calculation here. Let me just resize this. So let's see. Let's go with the global similarity. And write in here global similarity. So let's see. Okay, so again, following the formula here, let me just write. It says 1 divided by the total weight, which is 5, close parenthesis here, point, or multiplied by, just add them, add all of this, 0.250 plus 1 let me just put it on here so that you will see. One plus 0.667 plus 1 plus 0 equals, then you could place it here. Okay, it's just simply like this. So 1 over 5, which is the total weights here, we could calculate it earlier. 1 out of 5, which is this 1 plus 1 plus 1 plus 1 plus 1. So we have 1 out of 5. Okay, so this is actually Control Z. This is actually equivalent to how much? Tell me please. Go with the calculator. This close parenthesis, 1 out of 5 multiplied by 0.250 plus 1 plus 0 0.667 plus 1 plus 0 close parenthesis equals 0.583. 0.583, or this is equivalent to 58.3%. Okay, can we do the same for the next one? So for the next one we could write here, oh sorry, we could write in here 1 divided by 5 multiplied by 0.750 plus 1 plus 0.333 plus 0 plus 1 equals 1 over 5 dot 0.750 plus 1 plus 0.33 plus 0 plus 1. We will get, oh sorry, I made a mistake on that. 1 over 5 multiplied by 0.750 plus 1 plus 0.333 plus 0 plus 1 equals this one, which is 0.62. 0.62 oh 0.01617, sorry, 6117, or is equivalent to 61.7%, right? Next, we could go with the next one. This is 1 divided by 5 multiplied by 0.250, sorry for this, plus 0.250 again, plus 1 plus 1 plus 0 close parenthesis equals, how much is this? One half. So this is 50 SD. We'll get 0.500, or simply this equivalent to 50%. How about the next patient 4? Patient 4 is having what? This is again 1 over 5 multiplied by close parenthesis, which is 0.750 plus 0.750 plus 0.667 plus 1 equals, okay, this is 7.50, 667 plus 1 plus 1. Let's calculate this. This is how much? This is how much? 0.833. 0.833, or this equivalent to 83.3%. How about the next one? Paste here. This again 1 over 5 dot close parenthesis. Let me just take it in here so that you will see, and later on I'll get it. Patient 4, right? Patient 5, sorry. So we're working with patient 5. The value for patient 5 would be 0.750 plus 0.750 plus 0.667 plus 1 plus 1 equals how much?
0.833.
Same, right?
Yes.
Same with this. So let us put it here. This is also equivalent to how much? 83.3%. How about the last one? I think it's the same, right? Correct? It's the same, right? 750, 750, 667, 11. So just copy this.
Yes, same.
Good. So let's now predict what would be the sickness of this person. Because based on this calculation, we have three, right? Three similar findings. Three here. 0.83. All of these are having the same findings. So let's see the cases of 4, 5, 6, what if they have kidney problem or not. Case 4, 5, 6, it says no, right? No, correct? So, meaning we can conclude that patient 7 or patient X has no kidney problem. So we can now conclude that patient X, oh sorry, patient X has no chronic kidney disease based on the similarity of cases with patients with which patients with patients 4, 5, 6, right? 4, 5, and 6. So this is our conclusion. Okay, so patient X has no chronic kidney disease based on the similarity of cases with patients 4, 5, and 6. So this is the way on how you do the shortcut when you do the calculation. So present everything in a table like this and do the calculation also in this table. So in this way, this is a lot faster than doing it on the first method. The first method was just only an illustration in order for you to visualize how each calculation is being made. But during the examination, in the midterms and in the final examination, better you have to prepare table like this. Calculation is very fast if you have the table like this. So you have to write all the formula in each cell, then calculate it. All you have to do is maintain a feature like this, write the new case at the bottom of the table like this, okay, and then calculate the range at the bottom like this, like what we have done earlier, and then do the calculation. So write the formula. If you're working with continuous, then you have to write the formula for continuous here, 1 minus a, which is new, minus 90, which is the old, of the range, which is here at the bottom. Okay, so the technique is, it's very simple. If you have noticed if the old and the new, they have exactly the same value, automatically just have to write 1. Okay, of course you have to write the formula, but you don't have to calculate in the calculator, because obviously speaking, if they are the same, automatically they will get 1. Okay, so if you will notice the range of similarity between old and new is ranging from 0 to 1, right? Have you noticed it? From 0 to 1, the range here. So if they are very similar, then they will get 1, or at least very near to 1. So the halfway is 0.5. If you will see it, the in between is 0.5. Have you noticed? So as the value goes very near to your case, and then ranges will be somewhere here on this area. If similarity is very far, you will notice that the value are here. Let's say for example, if you have noticed, let's say if I have 7 as my A is 7, automatically 8 and 9, since they are very near to 7, they will get around 95% similarity, right? If you will notice it, or around 90%, because they are very near to your new case here. So if you will notice, as the old case becomes very huge in the difference, values will range from 0.5 up to 0 depending on the values here. Let's say for example, in this case, you will see that 80 and 70, they have the same value, right, which is 0.75, because our case is actually 75. So meaning, if my new case is 75, if you're going to analyze it, if it is 75, 80, what's the difference between 80 is 5, right? And the difference between 70 is also 5. That's why I expect 80 and 70, they will have the same value here, because they have the equal difference. 80 is 5 plus, right? Or plus 5, higher. 70 is minus 5, or 5 points lower than 75. Both of them, they will get the value, the same value. If you will see here, both of them, they got 75. So this is how we perceive the calculation here in this example. And also, if you encounter same cells having the same value, you don't have to recalculate again. Just simply copy the formula and paste it in there, because there is no sense, right? There is no sense in recalculating if cells, they have the same value. So in that way, you could speed up the computation. Okay? So anything you want to ask me?
Doctor, and the
Yes,
global,
doctor.
from where did you get 1 by 5?
1 over 5?
Yes.
It is it's the sum of the weights. The formula says, it says in here, this one, the sum of weights, this one, 1 over the summation of the weights. When you say summation, meaning total of the weights, okay? Whenever you see this symbol, it means summation, or total of the weights. So the weights, we got them from the attributes, okay? So in this example, we assume that blood pressure is 1, albumin is 1, the weight of sugar is 1, and red blood cells is 1. That's why we just simply add them, all of them. 1 plus 1 plus 1 plus 1 plus 1 equals 5. That's why we have 1. We have 5 here. That's why we have 1 over 5 as required by the formula here, which is 1 over the total weights. Okay? But some cases, like let's say for example in the dam, the last example we have last meeting, some of the columns, they have higher weights, right? I think it's Pahang, and what's the other dam, if you remember, in the last example. Let me just revisit it. I think we have it. We still have it. I think this one. Okay. So in this example, if you will notice, Pahang and Pekan, they have 2. So that's why we have to do the calculation in such a way. Pahang and Pekan should have 2 in the weights. Okay, look at this. 1 over summation of weight, we have 1 divided by 1 plus 2 plus 1 plus 2 plus 1. Because pahang and pekan, they have weights of 2. The rest of the attributes, they only have 1. Okay, so these are the weights. Water level is 1, pahang is 2, soy is 1, pekan is 2, gambang is 1. So please remember, ladies and gentlemen, when the weights are not expressed in the problem, automatically all of them will get 1. Because if you're going to put 0, what will happen? The answer will be 0, right? Because look at this. 0 multiplied by this, everything will become 0. That is why automatically you have to assume, when in the problem it's not stated the weights of the columns, automatically all the columns will get the weights of 1. But in this example, in the problem itself, we express that river pahang and river soy should have the weights of 2. That's why we have to emphasize it here. 1 over 1 plus 2 plus 1 plus 2 plus 1. So this is the calculation for the summation of weights. Now in the calculation, if you will see, we did this one. 1 times 1, 2 for pahang, 1 times for the other river, and then 2 for soy here. Have you noticed? So weights were included in this examples. Clear? But in our example here, we don't have to include. I hear somebody speaking. Mahara. But in this example, if you have noticed, in this example, we did not include the weights, right? Because it's nonsense to multiply them by 1 times 2.5 plus 1 times 1 plus 1 times 667 plus 1 times 1 plus 1 times 0. No need to write that if all of them they have the equal weights of 1. But if the case requires you to consider the weights for each column, then you have to state it in the formula here.